Take a deep, slow breath in, and as you exhale, let your body settle completely into the soft surface beneath you. Allow the gentle rhythm of your breathing to carry you far away, to the warm, quiet earth of the Yucatan Peninsula. What is fascinating about this vast expanse of dense Mexican jungle is that, despite the heavy tropical rains that fall here, there is not a single surface river to be found. Instead, the entire Yucatan Peninsula sits upon a massive flat platform of porous limestone. It acts essentially like a gigantic geological sponge. Over millions of years, the rain has seeped directly through the forest floor, carving out a secret subterranean world beneath the roots of the jungle. Down there, hidden from the intense tropical sun, flows an intricate web of underground rivers. Here is something most people don't know. Geologists estimate there are between 6,000 and 10,000 sinkholes scattered across this peninsula, serving as natural skylights into these submerged rivers. The ancient Maya called these openings Cenote, a word that eventually evolved into the modern term we use today, cenote. They considered these natural wells sacred, and as we step closer to the edge of one, it is easy to feel why. Imagine standing on the soft, leaf-strewn floor of the jungle, the air thick with the sweet, heavy scent of tropical orchids and damp soil. Just ahead of you, the earth opens up into a wide, circular chasm. Peering over the edge, you can see a steep drop, the walls composed of pale, textured limestone. Clinging to these rocky walls are the thick, fibrous roots of the alamo tree, scientifically known as Ficus aurea. These remarkable trees are uniquely adapted to this environment. Their roots grow continuously downward through the porous rock ceilings, sometimes dropping up to 50 feet through the open air, just to reach the vital water table below. If you were to run your hand along one of these hanging roots, you would feel a rough, bark-covered exterior that hums with the slow, steady draw of moisture, traveling upward to the canopy. As we slowly descend a carved stone staircase into the mouth of the cenote, you can feel the temperature of the air begin to shift. The intense, radiant heat of the jungle fades, replaced by a profound, enveloping coolness. The air inside the partially enclosed sections of these caverns maintains a humidity level of nearly 100%. With every breath you take, you inhale the distinct, remarkably clean scent of wet limestone and pure, filtered water. It is an earthy, grounding aroma, free from the dust and pollen of the world above. At the bottom of the stairs, a perfectly still pool of water waits. Stepping into this subterranean river is a deeply soothing experience. The water temperature in these underground systems remains incredibly stable, resting at a constant 76 to 78 degrees Fahrenheit, or about 24 to 25 degrees Celsius, every single day of the year. It feels exceptionally soft against the skin, neither startlingly cold nor overly warm, but a perfect neutral embrace that instantly relaxes the muscles. Near the surface opening, you might notice the water has a faint golden hue. This is due to natural tannins. As jungle leaves fall from the canopy and decay in the rainwater above, they release organic compounds that steep into the water, much like a mild, earthy tea. But as we gently submerge and float away from the opening, drifting deeper into the cave system, the water becomes unimaginably clear. The porous limestone of the Yucatan acts as one of the most efficient natural water filters on the planet. As rainwater slowly percolates down through the bedrock, impurities are stripped away. Because of this phenomenal natural filtration, the visibility in these underground rivers often exceeds 100 feet or 30 meters. Opening your eyes underwater here feels like floating in pure air. you experience a profound sense of weightlessness, suspended in a liquid crystal environment. As we glide deeper into the subterranean network, the true scale of this hidden world reveals itself. We are entering Sistema Sac Actun, which currently holds the record as the longest underwater cave system in the entire world. Explorers and cave divers have mapped over 347 kilometers, about 215 miles, of interconnected flooded passageways. It is a quiet, sprawling labyrinth of submerged beauty. Floating through these corridors, surrounded by the gentle rhythmic sound of your own slow breathing, you are drifting through deep time. The pale limestone rock walls that surround you are composed of calcium carbonate. What is truly amazing is that this rock was formed from the crushed shells and calcified skeletons of ancient coral reefs, dating back to the Cretaceous period, over 65 million years ago. But if you were to gently touch the wall of the cave, your fingers would trace the smooth, cool ripples of stone that were once teeming marine life, long before the peninsula was ever lifted above the ocean. Hanging from the ceilings of these submerged tunnels are magnificent speleothems, the scientific name for stalactites and stalagmites. These formations give the caves the appearance of an ornate underwater cathedral. But these structures did not form underwater. They grew during periods of Earth's history when global sea levels were drastically lower, leaving these caves dry. A single stalactite grows at an incredibly slow, patient rate of about 1 inch every 100 years. They are formed as single drops of mineral-rich water, gather on the ceiling, cling for a moment, and fall, leaving behind a microscopic deposit of calcite. To look upon a stalactite that is 10 feet long is to look upon a quiet, undisturbed natural process that took over 12,000 years to complete. The scale of time here is deeply comforting. There is no rush. Everything unfolds exactly as it should, drop by drop, century by century. As you drift peacefully through the illuminated pockets of the cave, where shafts of sunlight occasionally pierce down from small cracks in the jungle floor, you might experience a fascinating natural phenomenon known as a halocline. Because the Yucatan aquifer is connected to the ocean, the heavier, denser salt water from the nearby Caribbean Sea seeps inland through the deep bedrock. Meanwhile, the lighter, fresh rainwater floats gently on top of it. Where these two distinct bodies of water meet, they do not immediately mix. Instead, they form a visible boundary, the halocline. If you slowly descend through this layer, the water around you suddenly becomes blurry and distorted, like looking through a pane of frosted glass or a mirage on a warm road. As you cross the threshold into the saltwater layer, you can feel a subtle, comforting shift in temperature. The saltwater below is naturally a few degrees warmer than the freshwater above. It wraps around you like a gentle, heavy blanket. Once completely through the halocline layer, the water instantly becomes crystal clear again. In this peaceful, dark silence, life has found a way to thrive in perfect harmony with the environment. Gliding smoothly through the water are tiny, delicate creatures known as blind cavefish, or Astyanax mexicanus. Having evolved for thousands of generations in complete darkness, and these small, translucent fish have entirely lost their eyes. Instead of sight, they navigate the vast underground rivers using a highly developed sensory organ called a lateral line system. This line of microscopic receptors runs down the length of their bodies, allowing them to sense the most minute changes in water pressure and current. They can feel the gentle displacement of water as you drift by, seamlessly swimming around you in total darkness without ever making contact. It is a quiet, elegant ballet of survival, relying entirely on the subtle sensations of movement and touch. The slow, steady flow of these underground rivers is driven by a grand geological design. 66 million years ago, a massive asteroid impact created the Chicxulub crater on the northern edge of the Yucatan Peninsula. The impact fractured the deep limestone bedrock, creating a semicircular trough. Over millions of years, this fault line guided the flow of groundwater, resulting in a perfectly curved ring of cenotes that can still be mapped today. You can almost sense the gentle, eternal pull of this ancient gravity, continuously drawing the fresh water from the heart of the jungle outward toward the coast. This silent aquifer is always in motion, even if it is too slow to feel. Every single day, these subterranean rivers quietly discharge billions of gallons of pure, fresh water into the Caribbean Sea through submarine springs scattered along the coastline. It is a magnificent ongoing cycle. The ocean evaporates into clouds. The clouds rain over the dense jungle canopy. The jungle filters the water deep into the ancient limestone, and the slow, dark rivers patiently carry it back to the sea. You are a temporary, peaceful visitor within this endless rhythm. As the gentle current cradles you, supporting your weight entirely, you can simply let go. There is nothing to do here but observe, to feel the cool, soft water, to appreciate the quiet history of the stone, and to float securely in the heart of the earth. The gentle current carries you further along the submerged limestone corridor, moving with a slowness that defies the frantic pace of the world above. Picture this environment not as it is now, flooded and quiet, but as it was during the late Pleistocene epoch. Our understanding of this subterranean network stretches back far beyond modern memory. During the peak of the last ice age, around 20,000 years ago, global sea levels were roughly 400 feet, or 120 meters, lower than they are today. Because the ocean was so far recessed, the entire aquifer system drained, leaving these colossal caves completely dry. It was during this ancient window of time, roughly 13,000 years ago, that humans first walked upon the floors of these exact tunnels. Deep within a massive cavern known as Hoyo Negro, or Black Hole, archaeologists discovered the remarkably preserved remains of a teenage girl they named Naya. Her presence proves that early Paleo-Americans sought out these caves for shelter and fresh water. Beside her, resting peacefully in the dark, pale sediment, scientists identified the bones of magnificent extinct creatures that also wandered into the cool shade of the caverns. They found the remains of Gomphotheres, an elephant-like herbivore, and a previously unknown species of giant ground sloth, formerly named Cibalbionix oviceps. Today, the rising waters of the Holocene epoch have gently swallowed these dry floors. The cave water now acts as a perfectly still, liquid time capsule, without oxygen-rich air or harsh weather to degrade them. These artifacts and fossils remain in a state of tranquil, suspended animation, resting undisturbed for millennia. Centuries later, human understanding of this subterranean world evolved dramatically with the rise of the ancient Maya civilization. They did not view these sinkholes merely as geological formations, but as the literal sacred entrances to Xibalba, the peaceful underworld. The Maya strategically built their most magnificent cities directly over these hidden water sources. Consider the famous city of Chichen Itza. Its very foundation and layout were dictated by the presence of 4 massive cenotes located at the cardinal directions around the city center. During the harsh tropical dry season, which can last for 5 to 6 months on the Yucatan Peninsula, These underground rivers provided the only reliable source of fresh water for tens of thousands of people. Resting on the submerged floors near these ancient settlements, modern explorers routinely find beautifully intact Maya pottery. Often, these clay vessels are adorned with Maya blue, an incredibly resilient pigment. By chemically analyzing this paint, researchers discovered it is a unique mixture of organic indigo dye and a specialized clay called palygorskite. Even after soaking in the subterranean rivers for over 1,000 years, the vibrant azure color remains perfectly brilliant, contrasting softly against the white limestone sand. At this very moment, modern scientists read the history of this environment, not just through human artifacts, but through the stone itself. The stalagmites rising from the cave floors serve as geological tape recorders, capturing the quiet melody of ancient weather patterns. Paleoclimatologists harvest small cross-sections of these formations and analyze them using uranium-thorium dating techniques. Because the stalagmites grew only from the slow dripping of rainwater, varying layers of calcite reveal precise rainfall records from thousands of years ago. By reading these mineral rings, much like a botanist reads the rings of a towering tree, researchers have mapped historical periods of heavy tropical rainfall and severe drought, allowing us to understand the ancient climate that shaped the Maya civilization. The creation of these vast chambers is an ongoing, nearly imperceptible chemical ballet known to geologists as epigenic karstification. As rain falls through the atmosphere and soaks into the decaying leaf litter on the jungle floor, it absorbs carbon dioxide. This mixture creates a very weak carbonic acid. When this incredibly mild acid reaches the uppermost layer of bedrock, a stratum known as the Carrillo Puerto Formation, dating back to the Miocene and Pliocene epochs, it slowly dissolves the calcium carbonate. It is a process of subtraction that takes millions of years, hollowing out the Earth molecule by molecule to create the serene, flooded cathedrals we float through today. Notice how the water behaves as we observe the higher, drier sections of the cavern ceilings. Just above the waterline, where the air meets the stone, a quiet ecology thrives in the twilight zone. Clinging to the rough, textured limestone are colonies of cave myotis bats. They roost peacefully in the humid, sheltered warmth. As they settle into the crevices, they emit faint, high-pitched echolocation clicks that bounce harmlessly off the wet walls. Far from being isolated from the water below, these bats are the vital architects of the cave's food web, and their nutrient-rich guano falls directly into the slow-moving rivers. In an environment completely devoid of sunlight and plant life, this organic material provides the foundational carbon and nitrogen required to sustain the delicate aquatic food chain. Sharing this twilight airspace are cave swallows, scientifically named Petrochelidon fulva. They construct intricate cup-shaped mud nests along the sheltered cave mouths, bringing tiny morsels of damp earth from the jungle above to build their nurseries in the safety of the cenotes' overhanging lip. The sounds of their soft wings fluttering echo gently, blending with the rhythmic drip of condensation. Further back, in the absolute lightless depths of the aquifer, where no organic matter from the surface can reach, life relies on an entirely different mechanism for survival. Scientists discovered a process here called chemosynthesis. Specialized bacteria blanket the limestone walls, surviving not by converting sunlight into energy, but by extracting it from hydrogen sulfide naturally present in the deeper water layers. These bacterial colonies form soft, white, veil-like mats that sway slightly in the microcurrents. Swimming gracefully near these bacterial mats are some of the oldest living species on the planet. One such creature is the remipede, specifically Cibalbanus tulumensis. These blind, pale crustaceans look somewhat like tiny aquatic centipedes. What is extraordinary about remipedes is their evolutionary stasis. Fossil records indicate that their physical structure has remained virtually unchanged for over 300 million years. They maneuver through the pitch-black water, using dozens of pairs of swimming legs that ripple in a mesmerizing, undulating wave, allowing them to glide silently through the deep. Observing this world requires an immense amount of patience and specialized care. Modern human exploration of these flooded dark zones only truly accelerated in the 1980s. When certified cave divers enter these spaces, they carry thin, continuous nylon guidelines, often referred to as an Ariadne's thread. They carefully secure this line to rock outcroppings as they move forward, ensuring they always have a physical, tactile path leading back to the natural light of the cenote entrance. To study the fragile environments without causing disturbance, many researchers now use advanced closed-circuit rebreather systems, unlike traditional scuba gear, which releases loud columns of exhaust bubbles that could easily dislodge ancient sediment or damage delicate speleothems. A rebreather recycles the exhaled air. It quietly scrubs away carbon dioxide and injects precise amounts of pure oxygen back into the loop. This technology allows humans to remain submerged for up to 6 hours at a time, floating in absolute silence, integrating seamlessly into the quiet rhythm of the cavern. You might assume that a river must flow with noticeable force, but the water velocity in these subterranean channels is astonishingly mild. Hydrologists have measured the flow rate here, finding that the water often moves at a speed of mere millimeters per second. It is a migration so gentle it cannot be felt by human skin. At this patient pace, a single drop of rain that falls in the dense center of the Yucatan Peninsula may take several decades to finally reach the bright coastal waters of the Caribbean Sea. This slow, deliberate journey reminds us that there is no need to rush. The water has known its path for millions of years. It navigates the dark layers of Miocene limestone, brushes past the fossilized remains of ancient giants, and supports the quiet, blind life of the deep, all without ever altering its serene, unhurried pace. By floating within this history, suspended in the cool, clear current, you become part of an unbroken lineage of profound subterranean peace. Moving smoothly along this quiet subterranean path, the structure of the surrounding stone begins to reveal its true nature. To truly grasp the architecture of this environment, picture a common kitchen sponge. When dry, a sponge is stiff and lightweight, full of empty pockets. But when submerged, it eagerly pulls liquid into every available cavity. The limestone of the Yucatan Peninsula behaves in the exact same manner. Geologists measure this property as porosity, and this specific bedrock boasts a porosity rate ranging between 15 and 50%. It is utterly riddled with microscopic voids. Because of this sponge-like structure, the aquifer holds an estimated 3,200 cubic kilometers of groundwater. To put that massive number into perspective, that is roughly equivalent to the entire volume of Lake Erie, hidden completely out of sight beneath the forest floor. Observe how the water interacts with the cave ceiling in the partially air-filled chambers above us. Sometimes, in perfectly still pools isolated from any dripping water, you can find delicate formations known as calcite rafts. Imagine the thin, brittle layer of ice that forms over a winter puddle, or the delicate, cracked crust on the surface of a pastry. Calcite rafts are incredibly thin sheets of crystallized calcium carbonate, usually measuring just 0.1 to 2 millimeters in thickness. They form flat on the surface of the pool, held aloft purely by the physical force of water's surface tension. If a single drop of condensation were to fall from the ceiling and strike the raft, the surface tension would break, and the tiny mineral sheet would slowly flutter to the bottom of the pool like a falling leaf. Consider the other shapes protruding from the walls around you. While typical stalactites hang straight down, pulled by gravity, and this cave contains peculiar, twisted formations called haloctites. They grow sideways, curving in unpredictable spirals and delicate hooks that seem to defy gravity entirely. They achieve this through a process familiar to anyone who has watched a paper towel soak up a spilled drop of water. The central canal of a haloctite is so impossibly thin that hydrostatic pressure and capillary action override the downward pull of gravity. The mineral-rich water is drawn laterally through the microscopic tube, depositing calcite in twisting horizontal branches. At this precise depth, the water composition undergoes a fascinating shift. If you were swimming in a rushing mountain stream, the water would be vigorously tumbling over rocks, absorbing oxygen from the air. Surface rivers typically contain 8 to 10 milligrams of dissolved oxygen per liter, but here, deep inside the bedrock sealed away from the atmosphere, the water is hypoxic. The dissolved oxygen levels plummet to less than 1 milligram per liter. Being in this water is akin to standing on the peak of a high-altitude mountain, where the air is incredibly thin. Because of this low oxygen, the environment functions much like a deep desert, completely devoid of large, energy-demanding creatures. Instead, the ecosystem relies on highly efficient specialists. Gliding through the water is a tiny translucent crustacean called the blind cave shrimp, scientifically classified as Crioceria morley. It measures barely 3 centimeters long. You can think of these shrimp as the diligent microscopic vacuum cleaners of the aquifer. They are detritivores, surviving by meticulously scavenging the microscopic organic particles that drift down from the jungle above. They paddle tirelessly with their fine, feathery appendages, keeping the cave environment impeccably clean. As we traverse further into the system, perhaps visiting the legendary depths of Cenote Angelita, you might witness an optical illusion that is famous among deep-water explorers. At a depth of approximately 30 meters, or nearly 100 feet, you encounter what appears to be a thick rolling river flowing beneath the water itself. It looks exactly like a dense, heavy layer of morning fog trapped in a valley, complete with skeletal tree branches emerging from the mist. This is not a second river, but rather a concentrated cloud of hydrogen sulfide. It is created when organic matter, like leaves and twigs, sinks into the saltwater layer and decays without the presence of oxygen. The resulting gas becomes trapped directly on the boundary line between the fresh water above and the heavier salt water below. The cloud is usually about a meter thick, colored a pale, ethereal green. If you gently wave your hand through it, the fog swirls and parts around your fingers, just like smoke, before settling perfectly flat once again. Notice how, even deep inland, the aquifer is secretly synchronized with the cosmos. It might seem impossible given how far we are from the coast, but the water level in these caves experiences daily tides. The vast porous limestone acts somewhat like a hydraulic extension of the nearby Caribbean Sea. As the moon's gravity pulls on the ocean, the changing pressure transmits through the underwater saltwater layer, pushing up against the freshwater above. Even several kilometers into the jungle, sensors detect the water in these cenotes, quietly rising and falling by 10 to 20 centimeters twice a day. It is as if the entire subterranean system is slowly, rhythmically breathing in time with the ocean. Pay attention to the acoustics of this submerged space. Above ground, when a bird sings, sound travels through the air at roughly 343 meters per second. But water is incredibly dense compared to air. Think of how a solid oak door transfers a knock much better than a hollow one. Because of this density, sound in these rivers travels at an astonishing 1,480 meters per second, approximately 4.3 times faster than it does on the surface. If a loose pebble shifts on the cave floor far ahead of us, the sharp acoustic click reaches you almost instantly, ringing with the crisp clarity of a perfectly tuned concert hall. The water is an exceptional conductor of vibration, connecting every corner of the cave through a shared, instantaneous acoustic web. Above us, the ceiling is occasionally pierced by the determined roots of the ramon tree, or Brosimum allicastrum. This towering canopy tree produces a nutrient-dense nut that was a staple of the ancient Maya diet. But its survival strategy below ground is what is truly spectacular. Rather than just spreading horizontally through the shallow topsoil, like a typical garden plant, the ramon tree sends thick, exploratory taproots plunging up to 30 meters straight down through the solid limestone fractures. They follow hair-thin cracks in the rock, exerting immense, slow hydraulic pressure over decades to widen the fissures just enough to reach the subterranean water. Think of these roots as thick wooden fiber optic cables, continuously transmitting the cool, mineral-rich water from this deep aquifer all the way up to the sunlit canopy. They provide a vital, living bridge between the dark, silent world below and the vibrant, chattering jungle above. Scientists categorize the openings that these roots utilize into 4 distinct geological shapes, much like varying household containers. Some cenotes are classified as jug-shaped, featuring a small, narrow opening at the top that flares out into a massive, cavernous room beneath the surface. Others are cylindrical, presenting perfect steep-walled tubes that drop straight down like an elevator shaft. There are basin cenotes, which resemble wide, shallow bowls open to the sky. And finally, cave cenotes, which remain almost completely enclosed by a limestone roof, accessible only through a small side entrance. Navigating through these varying geometries, the water molds perfectly to its container. It asks nothing, forces nothing, and simply fills the spaces it is given. It is a profound masterclass in adaptation and patience. As you observe the water's quiet journey, filtering through the sponge-like rock, balancing the fragile calcite rafts, parting around the hydrogen sulfide clouds, and rising with the distant ocean tide, you can sense the incredible stability of this environment. It is a world entirely isolated from the noise and weather of the surface, governed only by the slow, gentle laws of geology and time. As we follow the subterranean channels closer toward the coast, an entirely new dimension of this environment reveals itself. A common misconception is to imagine these rivers as isolated pipes, sealed completely from the world above. But nature rarely operates in such strict divisions. Here, the boundary between the terrestrial jungle and the aquatic underground blurs into a beautifully interdependent system. The water you are currently observing is a lifeblood not just for the cave dwellers, but for an astonishingly vast network of coastal ecosystems. Think of how your own body relies on a network of arteries to deliver essential nutrients to every extremity. The Yucatan aquifer functions in a strikingly similar way for the Mexican Caribbean. Just offshore, running parallel to the eastern edge of the peninsula, lies the Mesoamerican Barrier Reef System. Measuring over 1,000 kilometers long, it is the second largest coral reef system on our planet. It is a vibrant, bustling metropolis of marine biology. What most people are unaware of is how deeply this offshore coral reef depends on the silent, dark rivers beneath the jungle. Remember how the water absorbs calcium carbonate as it slowly dissolves the ancient limestone bedrock? By the time the underground river reaches the ocean, it is carrying an incredibly rich payload of dissolved calcium and bicarbonate ions. Every day, through natural underwater springs called ojos de agua, or eyes of water, the aquifer gently exhales this mineral-rich freshwater directly into the warm Caribbean Sea. This process is critical. The coral polyps out on the reef, the tiny soft-bodied organisms that actually build the massive coral structures, require immense amounts of calcium carbonate to secrete their hard, protective exoskeletons. The slow, steady discharge from the aquifer acts as an ongoing mineral delivery system. Without the quiet work of the underground rivers dissolving the inland stone, the spectacular coastal reefs would struggle to find the building blocks necessary to grow and repair themselves. It is a beautiful, large-scale recycling program. Ancient fossilized coral inland is dissolved by rainwater, carried through the dark, and offered up to build new. Living coral off the coast. Just before these rivers meet the open ocean, they create unique estuarine environments in the coastal lagoons. In places like Sac Actun, a massive UNESCO World Biosphere Reserve, the mixing of the aquifer's fresh water with the ocean's saltwater creates the perfect brackish habitat for massive mangrove forests. The red mangrove, known scientifically as Rhizophora mangle, thrives exactly at this intersection. Look closely at a red mangrove tree, and you will see an intricate tangle of prop roots arching out from the trunk and plunging directly into the water, looking much like the long legs of a wading spider. These specialized roots serve a dual purpose. First, they provide immense structural stability in the soft coastal mud. Second, they act as sophisticated biological desalination plants, and the roots possess a specialized cellular membrane that physically filters out up to 90% of the salt from the surrounding water, allowing the tree to drink. As the tree processes the water, it sometimes expels the remaining salt through tiny pores in its waxy green leaves. In the morning light, you can actually see the leaves glittering with fine white salt crystals. Beneath the water's surface, these mangrove root systems create a safe, tangled nursery. They offer essential protection for the juvenile stages of countless marine species. The critically endangered Goliath grouper, Epinephelus itajara, spends the first 5 to 6 years of its life hiding in the intricate shadows of these mangrove roots. Sheltered from the strong ocean currents and nourished by the nutrient-rich water flowing out from the cenotes, these small fish eventually grow into gentle giants that can weigh over 800 pounds. The interconnectedness of this system is further demonstrated by the unique hydrology of the coastal cenotes themselves. As you approach the shoreline, the bedrock becomes thinner, and the influence of the ocean becomes more pronounced. Some of these coastal sinkholes, such as Cenote Manati, also known as Casa Cenote, are essentially open-air channels, connecting directly to the sea. The water here is distinctly brackish, a seamless blend of the aquifer's slow seep and the ocean's gentle push. Because of this unique salinity, you find an extraordinary overlapping of species that would rarely meet elsewhere. It is entirely possible to see freshwater tetras swimming alongside marine barracudas. More remarkably, these coastal cenotes provide crucial refuge for the Antillean manatee, Trichechus manatus. These large, slow-moving marine mammals require regular access to fresh water to survive. During the dry season, they navigate up the narrow mangrove-lined channels from the ocean, sliding quietly into the clear, cool cenotes. An adult manatee can weigh up to 1,300 pounds, yet they move with surprising grace, using their paddle-like tails to maneuver through the submerged limestone canyons. They come here to rest, to drink the pure aquifer water, and to gently graze on the specific varieties of seagrass that flourish in this brackish environment. As scientists map the furthest reaches of the aquifer near the coast, they utilize a specialized tracking technique using harmless, non-toxic fluorescent dyes. By injecting a small amount of dye, like uranine, into an inland cenote, researchers can patiently wait to see where the glowing green water eventually emerges along the coastline. This meticulous process has revealed that a single underground river system might have dozens of separate exit points scattered along miles of beach. It proves that the aquifer is not a single rushing stream, but a vast, slow-moving sheet of water, gently weeping out into the sea across an incredibly broad front. To map the physical structure of these coastal discharge zones, marine geologists employ side-scan sonar. Towed behind a small boat, this technology sends out fan-shaped pulses of sound that bounce off the ocean floor, creating highly detailed, three-dimensional acoustic maps. The sonar data reveals that the ojos de agua often appear as large, bowl-shaped depressions in the sandy seabed, sometimes up to 30 feet across. The upward pressure of the exiting freshwater constantly suspends the fine ocean sand, creating an effect that looks exactly like a gently boiling cauldron, even though the water temperature is perfectly mild. Observing this constant quiet exchange at the edge of the continent offers a profound perspective. It is easy in our daily lives to feel separated from the natural world, to view ecosystems as distant and distinct. But this environment proves that nothing in nature exists in isolation. The rain that falls on a leaf miles inland eventually becomes the shell of a crab on the coast. The slow decay of a jungle branch provides the carbon needed for bacteria in a lightless cave, which in turn supports blind crustaceans. When you consider the vast timescale of this process, it brings a deep sense of grounding. The limestone bedrock, formed over 65 million years, continues to slowly dissolve. The water takes decades to travel from the center of the peninsula to the reef. The coral builds its structure molecule by molecule, century by century. It is an immense, patient machinery of life, operating silently beneath our feet, completely undisturbed by the passing of human generations. As you visualize the gentle outflow of the fresh water, meeting the vast, warm expanse of the sea, you can appreciate your own place within this larger rhythm, a quiet observer, perfectly supported by the slow, enduring interconnectedness of the natural world. Gliding smoothly into an isolated, partially submerged chamber, where the water level drops just enough to expose a pocket of trapped air, a remarkable sensory environment unfolds. If you were to slowly emerge from the water and take a breath in this sealed cavern, you would instantly notice a rich, intoxicating scent. It is the absolute essence of damp earth, magnified. Scientists understand the origin of this specific fragrance. It does not actually come from the stone or the water itself, but from a naturally occurring chemical compound called geosmin. Geosmin is a metabolic byproduct produced by microscopic Streptomyces bacteria that thrive in the dark, humid soils directly above the cave ceiling. As rainwater percolates down, it carries this compound into the subterranean air. What makes this so profound is human biology. Our olfactory receptors are hypersensitive to geosmin. We can detect it at incredibly low concentrations of just 5 parts per trillion. To visualize that, It is equivalent to sensing a single drop of liquid mixed into an entire Olympic-sized swimming pool. This ancient evolutionary sensitivity to the scent of fresh water creates an immediate physiological sense of comfort and safety in the mind. Look closely at the surface of the water from beneath, looking up toward the gentle ripples. You will witness a stunning optical phenomenon known to physicists as Snell's window. Because light refracts or bends as it passes from the air into the denser medium of water, your view of the entire ceiling above is optically compressed into a perfect glowing circle directly overhead. This circle forms exactly a 97-degree cone of vision. Outside the boundary of that specific angle, the surface of the water ceases to be transparent. Instead, it undergoes total internal reflection, transforming instantly into a flawless liquid mirror that reflects the submerged limestone formations below. It creates a seamless, symmetrical illusion, making the cavern appear as an endless, floating sphere of stone. As you observe the soft ambient light filtering through the distant cenote entrance, notice the profound, crystalline blue of the water surrounding you. The mechanics behind this color are uniquely beautiful. Most objects in the world get their color from electrons absorbing specific wavelengths of light. However, water is one of the only known substances on Earth where its color originates entirely from atomic vibration. The chemical bonds connecting the hydrogen and oxygen atoms in water molecules physically vibrate. These tiny rhythmic vibrations naturally absorb the longer, warmer wavelengths of red and infrared sunlight. By absorbing the red, the water allows the shorter, cooler blue wavelengths to transmit clearly. You are essentially floating in a vast liquid prism, surrounded by a color generated by the subtle vibration of trillions of molecules. To fully appreciate the architecture of these walls, we can use the analogy of a geological photographic darkroom. Just as a physical photograph requires a specific chemical bath and absolute darkness to slowly develop its image, these spectacular mineral formations require precisely balanced chemistry and seclusion from the sun to materialize. The water seeping through the jungle soil above is highly acidic. Because the roots of the jungle trees are constantly respiring, the soil contains up to 100 times more carbon dioxide than the normal atmosphere. The rainwater absorbs this gas, becoming a potent solvent that dissolves the bedrock. What is happening now is a delicate reversal of that process. The air trapped inside this cave has a much lower partial pressure of carbon dioxide than the soil above. When the mineral-rich water droplet finally emerges from the ceiling and contacts the cave air, it suddenly outgasses, releasing its trapped carbon dioxide into the atmosphere, much like a carbonated beverage releasing a tiny bubble. This minute shift in chemistry immediately forces the dissolved calcium carbonate to precipitate out of the liquid, leaving behind a microscopic crystal of solid calcite. The steady, tsura, rhythmic sound of dripping water you hear echoing in the chamber is the auditory signature of the cave actively building itself, fraction of a millimeter by fraction of a millimeter. Run your imaginary hand along the submerged walls of the channel, focusing on the tactile feedback of the limestone. The texture here is not flat or random. Instead, it is patterned with thousands of smooth, spoon-shaped depressions, known to geologists as scallops. These scallops are formed by the friction of the moving water, dissolving the rock over countless millennia. By analyzing the specific geometry of these scallops, hydrologists can read the history of the current exactly like a map. Scallops are inherently asymmetrical. They feature a steep, abrupt ridge on one side and a long, gentle slope on the other. The steep side always faces directly into the ancient upstream current. Furthermore, the physical length of the scallop is inversely proportional to the speed of the water that carved it. Large, wide scallops, stretching several inches across, indicate a history of very slow, lazy currents. Conversely, clusters of tiny, deeply etched scallops reveal areas where the water once squeezed through tight constrictions at high velocity. Even when the water is perfectly still, the stone remembers the momentum of the past. At this exact moment, in the quietest, undisturbed corners of the sunlit cenote entrances, ancient biological processes are quietly unfolding. Clinging to the submerged rocks are lumpy, cauliflower-like structures known as microbialites. These are not ordinary stones, but living biogenic formations. They are built layer by layer by colonies of cyanobacteria, some of the earliest forms of life to exist on Earth. As these microscopic organisms photosynthesize the faint sunlight, they alter the microchemistry of the water directly surrounding them, trapping loose calcium carbonate and essentially gluing it to their surface. They construct their own rocky habitats at incredibly patient rates of less than 1 millimeter per year. Touching a microbialite is touching a biological process that has been occurring continuously in exactly this manner for over 3 billion years. Deep within the lightless zones, where cyanobacteria cannot survive, the walls host an entirely different kind of silent dweller, the cave sponge. Specifically, species like Cinacarella have adapted to thrive in these dark, anchialine environments, the scientific term for coastal aquifers that mix fresh and salt water. Visually, they look like small, pale spheres attached firmly to the bedrock. If you could magnify the surface of this sponge, you would not find the soft, yielding texture of a synthetic household sponge. Instead, their structural framework is constructed from thousands of microscopic, glass-like needles, known as silica spicules. These interlocking spicules provide a rigid protective skeleton. Inside this protective scaffolding, the sponge performs an astonishing mechanical feat. They are equipped with millions of specialized cells, called choanocytes. Each of these tiny cells possesses a whip-like appendage called a flagellum. By beating these flagella in perfect microscopic unison, the sponge generates its own internal water current. It draws the cave water in through tiny pores, extracts invisible microscopic organic particles for nourishment, and exhales the filtered water out through a central opening. The scale of this silent labor is monumental. A single fist-sized cave sponge can actively pump and filter up to 50,000 times its own volume in water every single day. They are the tireless internal purifiers of the aquifer, operating completely without a nervous system, brain, or moving parts, as we understand them. They simply exist, filtering the deep currents in an endless rhythm of intake and release. Floating among these quiet marvels, the perfectly tuned light of Snell's window, the intricate chemistry of the calcite drip, the geographical memory of the scalloped walls, and the continuous, the unseen breath of the cave sponges. You realize that nothing in this space is truly static. The subterranean world might appear frozen in stone, but it is deeply, continually active. It moves at a frequency completely detached from the haste of the surface. Here, a century is a brief moment. A single millimeter of growth is a triumph, and the slow vibration of water molecules provides all the color the dark will ever need. You are suspended in a masterpiece of physics, biology, and chemistry, perfectly balanced and infinitely patient. As our observation of this subterranean world begins to gently conclude, we find ourselves retreating into the most sheltered, undisturbed pockets of the aquifer. In these absolute depths, the frantic momentum of the surface world ceases to exist entirely. Instead, everything here operates through gradual, meticulous sequences, processes that unfold step by step, honoring the slow, undeniable rhythm of geological time. Here is a detail often overlooked about the water cradling you. It holds a specific chemical memory of its journey. When a single drop of rain first falls over the Yucatan, it carries a unique isotopic signature of the atmosphere from the exact moment it formed. As that drop lands on the jungle floor, the first step of its long transformation begins. It seeps into the topsoil, where it slowly absorbs humic acid from the decaying leaf litter. This mildly acidic drop then begins a remarkably patient downward migration through a massive limestone platform that measures up to 3,000 meters thick in certain regions, all of which was originally laid down during the Cretaceous period. By utilizing radioisotope tracing techniques, hydrologists have documented the timeline of this exact process. They discovered that it takes 50 to 100 years for a single droplet of water to travel from the central interior of the peninsula to the coastal discharge zones. As you breathe in and out, consider the profound patience of that journey. A century of silent, dark travel just to reach the sea. In the dry, air-filled chambers just above the waterline, an equally methodical process is taking place. It is the step-by-step creation of a rare geological formation known as a cave pearl, or an oolite. Unlike a pearl found in an oyster, a speleothem pearl forms completely independent of living tissue. The process begins with a microscopic nucleus, perhaps a single grain of quartz sand, or a tiny fragment of a fossilized bat bone, resting in a shallow depression on the cavern floor. What is truly captivating is the precise mechanics required for the next stage. A cave pearl demands a highly specific drip rate from the ceiling above. If the water drops too quickly, the kinetic energy simply washes the sand grain away. If it drips too slowly, the dissolved minerals cement the grain directly to the rock floor. But when the timing is absolutely perfect, a single drop of calcium-rich water lands, coating the nucleus. As the water evaporates, it leaves behind a microscopic layer of solid calcite. Step by step, decade by decade, the calcite crystal lattice naturally aligns in a trigonal system, building concentric layers around the core. Simultaneously, the physical impact of each subsequent water drop literally rotates the growing stone. This continuous, gentle turning prevents the pearl from attaching to the floor and polishes it into a perfectly smooth, spherical shape. A cluster of these polished cave pearls, resting quietly in their limestone nest, represents thousands of years of perfect rhythmic dripping. It is an enduring testament to the beauty of slow, repetitive motion. Below the surface of the pools, the biological life also operates through a series of slow, deliberate phases. Within this strictly subterranean environment, scientifically classified as a hypogean ecosystem, creatures have undergone a step-by-step evolutionary process to master the dark. Consider the Mexican blind cave Brochula, known to biologists as Typhliacina pierce. When the ancestors of these small fish first became trapped in these underground rivers thousands of generations ago, their bodies began a gradual energy-saving transformation. First, the fish halted the cellular production of melanin. Because there is no ultraviolet solar radiation in the cave to damage their skin, producing dark pigment was a waste of vital metabolic resources. Over time, their scales became entirely translucent, rendering them a ghostly, pale pink. In the next phase of adaptation, Their bodies drastically lowered their baseline metabolic rate. Today, the cave brotula moves with an incredibly slow, deliberate grace, hovering almost motionless in the water column. Through this extreme conservation of energy, they have developed the astonishing ability to survive for up to 6 months without consuming a single meal. Sharing this quiet habitat is another specialist, the blind cave isopod, Criaceriella aenops. Their survival relies on a methodical step-by-step scavenging process. Because they cannot see, they utilize highly sensitive chemoreceptors located on their antennae. When a tiny fragment of organic matter finally drifts down through the limestone fissures, it subtly alters the chemical composition of the surrounding water. The isopod detects this microscopic shift and begins a slow, deliberate navigation toward the source, tracing the invisible chemical gradient through the pitch-black water. Perhaps the most comforting biological reality of these deep cave dwellers is their relationship with time. Because they live entirely sealed away from the rotation of the sun and the moon, these species completely lack a circadian rhythm, and there is no biological morning, no afternoon, and no night. There is only a continuous, peaceful present. They rest when they need to rest, and they move when they need to move, entirely freed from the constraints of a daily clock. This environment is maintained by a process of ultimate stabilization. Above us, the creation of the cenotes themselves is the final stage of a geological sequence called epigenic karstification. Over tens of thousands of years, the flowing water slowly hollows out a chamber. Eventually, the limestone roof above becomes progressively thinner. This process of subaerial exposure continues until gravity simply overcomes the structural tension limit of the bedrock. In a single, natural moment of release, the roof gracefully collapses inward. This event creates a permanent karst window, an opening that gently reconnects the dark aquifer with the sunlit jungle above. Yet, down here in the secluded, uncollapsed corridors, the environment refuses to fluctuate. The sheer thermal mass of the millions of tons of surrounding bedrock continuously absorbs and slowly radiates ambient heat. Through this physical process, the water and the air temperature are forever equalized, locked at a perfectly stable 25 degrees Celsius or 77 degrees Fahrenheit. The cave air, constantly buffered by the vast sheets of water below, maintains a steady relative humidity of exactly 99%. It is a perfectly insulated sanctuary. Every sound is gently dampened by the porous rock. Every temperature shift is instantly neutralized, and every drop of water is caught in a soft, eternal embrace. As we observe the absolute stillness of this subterranean world, you can begin to align your own internal rhythms with the slow, step-by-step processes of the stone and the water. The gradual, patient filtering of the aquifer mirrors the gradual settling of your own thoughts. The total absence of a circadian rhythm in the dark, peaceful depths invites you to detach completely from the ticking of the clock, from the pressures of the day, and from the expectations of tomorrow. Allow the heavy, grounding thermal mass of the earth to anchor you exactly where you are. Just as the water is perfectly supported by the limestone basin, your physical form is perfectly, effortlessly held. There is no current you need to fight. There is no light you need to hide from. There is only the cool, clear stillness, settling layer by layer, drop by drop, into a state of profound, undisturbed rest. You are safe in the quiet. Your breathing slows, mirroring the patient drip of the cave. Every muscle releases its tension, heavy and relaxed, like stone resting on stone. Your mind becomes as clear and as still as the untouched aquifer. There is nothing to figure out, nothing to plan, and nothing to do. You are stepping seamlessly into the dark, comforting embrace of rest. The gentle rhythm of the earth carries you effortlessly, peaceful, supported, still. Good night.